All right, let's do this. Today, we are going to crack a code that's going to help you absolutely ace your next math test. We're diving deep into the world of decimals, and we're going to focus on those teeny tiny but super important numbers called thousandths.
So, you've got a big math test coming up, right? Yeah, I know, they can feel a little tricky sometimes, but don't you worry. We are going to tackle this together. And by the end of this, you're going to walk into that classroom ready to show that test who's boss.
You ever see a number like 0.750 and your brain just kind of goes, huh? Well, I want you to start thinking of numbers like that as a fun puzzle, or maybe even a secret code. And today, we're going to learn all the secret rules to crack it wide open. Okay, let's dive right in. The very first clue we need to crack this code is to figure out what a thousandth actually is. Once you really get this, I promise, everything else is going to start to click into place.
Okay, imagine you have a big chocolate bar, and you break it into 100 perfectly equal squares. Each one of those squares is a hundredth, right? Now take just one of those little squares and carefully slice it into 10 even tinier pieces. One of those little slivers, that's a thousandth. We are talking super, super small.
So here's the official math way to say it. A thousandth is just one part out of 1,000 equal parts. As a fraction, it's pretty easy to see, 1 over 1,000. But as a decimal, and this is what you'll see on your test, it's 0.001. And here's a huge clue. See those 3 numbers after the decimal point? That's your secret signal that we're talking about thousandths.
Awesome. So now that we know what a thousandths is, we need to learn how to speak its language. You know, reading and writing decimals is a lot like learning a secret code, and I am about to tell you the most important secret word of all. Check out this table. For 0.003, we just say 3 thousandths. Simple enough. But look at the next one, 1.065. We say 1 and 65 thousandths. See that word and? That is the secret password. In math language, and tells you exactly where the decimal point goes. It's like a bridge that separates the whole numbers on the left from all the tiny decimal parts on the right.
All right, you've learned the basics, you know the secret language. I think you're ready. It's time to put your new skills to the test. Let's put on our detective hats and solve a few real-world puzzles. Here's our first case. You see a sign at a gas station that says the price is $2.59 and 9/10 of a cent. Wait, what? 9/10 of a cent? How in the world are we supposed to write that as a regular number? Don't worry, let's break it down. The best way to solve any tricky problem is one small step at a time. So, step 1, let's just grab the easy part, the main price, which is $2.59. We'll write that down as 2.59. Easy. Now for step 2, the tricky part, 9/10 of a cent. Well, a penny is 1/100th of a dollar, or 0.01. So a tenth of that is even smaller. It's a thousandth of a dollar. That means 9/10 of a cent is 9 thousandths, which we write as 0.009. Okay, last step. Step 3, we just add our two pieces together. 2.59 plus 0.009 gives us our answer.
And bam! There it is, 2.599. See that? It looked really complicated at first, but when you break it into little steps, it's not so bad at all. First puzzle officially solved. Great work!
Okay, you're all warmed up. Let's try puzzle number 2. This one is all about comparing. So Jamila's trip is 1.08 kilometers. Leela's trip is 1.080 kilometers. And Leela says, ha, my trip is longer because 80 is a bigger number than 8. What do you think? Is she right? This puzzle is actually a classic trick question.
And that puzzle leads us perfectly into our next section. You gotta watch out for those zeros. Zeros can be sneaky little numbers in decimals, and they love to try and trick you on a test. But not you. After this, you are going to be a zero spotting expert.
So let's settle the debate between Jamila and Leela. Is 1.080 bigger than 1.08? Well, if we read them out, one is 1 and 80 thousandths, and the other is 1 and 8 hundredths. They sound a little different, but they're the exact same value. They're totally equal. So, sorry Leela, your trip isn't longer. It's the exact same length as Jamila's.
And this is a super, super important rule for your test, so listen close. Is 0 at the very end of a decimal, after all the other numbers, does not change its value. It's just a placeholder. 1.08 is the same thing as 1.080, which is the same as 1.080000. It's a really common trap, but now you know the secret.
Okay, so zeros at the end don't matter. Got it. But what happens if we stick a 0 right in the middle? Is 40 and 700ths the same thing as 40 and 7,000ths? Now this is a different story.
No way. These are absolutely not equal, not even close. You see, when a 0 is in the middle, between the decimal point and another number, it is a super important placeholder. In 40.07, that 7 is in the hundred spot. But in 40.007, that extra 0 pushes the 7 way over to the thousandth spot, which makes it a much smaller value. So remember, location is everything.
You have done an amazing job. Seriously. You've learned the language, you've solved puzzles, you've spotted the zero traps. Now let's put it all together and review the math test superpowers that you officially have. Okay, here they are, your superpowers. Number 1, the word "and" is your secret code for the decimal point. Number 2, zeros at the very end of a decimal are just for show. They don't change the value. Number 3, but zeros in the middle are powerful. They change everything. And number 4, your ultimate superpower, you can solve any problem by breaking it down into small, simple steps.
You've totally got this. You went from being a little puzzled by decimals to becoming a full-on code-cracking expert. So go into that test with confidence, use your new superpowers, and show everyone what you know. You're gonna do great. Now go ace that test!